Hey, could you hear me? This works? Okay. Hey, my name is Eitan. Sometimes I go by EJ. At this point, I'm a relapsing GNOME developer. I've been involved in the community long ago. Today I work mostly on Mozilla, at Mozilla and on Mozilla. And I want to introduce a passion project that I've been working on. Been very slow with a full-time job and everything, but I feel really good about the state it's in, and I think it's worth talking about. So speech is everywhere. I'm not going to spend too much time on this, but I would gauge, I don't know, maybe I would argue that that in the last decade there's been a lot of investment in speech interfaces, maybe even more than graphical interfaces at this point. If it started with screen readers, if that was the original application that speech was used on computers, especially in Linux, it's really evolved into automotive, navigation, e-reading, and all that, and of course all of the assistants and AI and all of the things that big tech is working on is something that obviously uses speech and depends on it. So 11 years ago, I implemented the web speech API in Firefox. And it kind of was hedging on the same bets that this is something that applications are going to want. They're going to want to speak. And this is what a snippet of what JavaScript, DOM JavaScript in the browser would look like that would make your browser talk. So I was working on that, and we decided that it was nice to have an API. Not many people knew about it, so we wanted to make it front and center and to have an actual user feature. So we created Narrate, which was part of our reader mode. You could see it work over here.
scientificamerican.com. How does the world's largest library decide what becomes history? Sarah Wild. 9-12 minutes. The world's oldest known library, the Royal Library of Ashurbanipal, in what is today Iraq, was created in the 7th century BCE to store clay tablets used for record keeping.
All right, and that's Windows, by the way, right? So this is the Windows, you can't really tell in Firefox anymore, but that's a Windows Firefox. This is what it looks like right now if you will open up the same page on your average Linux distribution.
scientificamerican.com. How does the world's largest library decide what becomes history? Sarah Wild. 9-12 minutes. The world's oldest known library, the Royal Library of Ashurbanipal, in what is today Iraq.
All right, I'm going to spare you from the rest of this. All right, so you could tell that when I was implementing this, we needed to normalize all these platforms. They all had different APIs, how they worked, and I found myself working in Matrix, trying to figure out which features are supported on which platforms, and both how do we translate that into an API in Firefox, but also how do we translate that into a user feature like Narrate. And you could tell that Linux, at least in this grid that I made up, is losing on all of those fronts. And we'll talk about all those different, actually, why don't we overview right now? So boundary events, the idea is that as you're speaking or as the voice is synthesized, you get like boundaries, like a word, you get word boundaries or sentence boundaries or even explicit boundaries within that utterance. You are told between which frames of audio that is happening, so you could give visual feedback. Pause and resume just as it sounds. It's just, being able to pause and resume, the sound. Now you could do that in Speech Dispatcher, or in Linux currently, but that requires knowing what offset you are inside the speech, which is a little problematic. Volume change, changing the volume like as the utterance is actually happening. Concurrent speech, and that's really big, and we're going to talk about that soon. And natural sounding voice. I think we all just heard what Linux sounds like and what Windows sound like and what that means. So this is currently the speech API that we have in Linux. It's called Speech Dispatcher. It was developed in 2001. And it's a very opinionated framework that really is meant for screen readers. That's really what it was developed for. What it does is it schedules utterances according to priority. So you could say, You could send a command to speak. You could send 10 commands to speak, and it will speak those things in order. Unless one of those commands has a high priority, then it's going to interrupt the rest of the queue. Or if they're competing, then it has like a whole model of how to manage priority and how to manage scheduling. And it's singleton, so that means it works in a global way. So if you have one app trying to speak, and another app that might have not the best intentions or doesn't really know how to use that priority model, it's going to interrupt, and both apps are going to have a very bad time. Now, multiply that with at least the problem that I was dealing with at the time, which was the web browser. You have all these tabs. Which tab the tabs are contending for speech. There's also, I think, some security concerns about that. If one tab could, interfere with the operation of another tab, I think I don't know. It seems very shady to me, the whole idea that tabs need to interoperate. Now, the problems that Speech Dispatcher tackled back in 2001 and today are things like auto spawning, wire protocols, IPC transport, sessions persistence, modularity, things that we kind of generalized. I'm not going to say how we generalize them because I'm going to get there, but those are things that we have generalized today. Yeah. And of course, the other thing is that Speech Dispatcher, it works with text files, and you configure it through text files, which allows people to sometimes misconfigure things and be out in the dark, or it makes it very hard to install new speech synthesizers like the one that we just heard. With all this said, there is space for Speech Dispatcher. There's obviously a use case to have that kind of ordered speech, and Speech Dispatcher does have a lot of very domain-specific features that are good for screen readers. So in this whole talk, I'm not necessarily a proponent of replacing Speech Dispatcher, but what is obvious that it does not work for all domains. So how did we end up with eSpeak? Well, it has a very simple license. It supports many, many languages. Last count from an hour ago, 132 languages, or at least variants and accents. It's very small. I don't know how I got to 1 megabyte there, but it is really, really small if you look at the tarball. It's fully featured. It does word tracking, it does SSML, it does all the things that you expect a speech synthesizer to do. It is extremely fast, and it is very responsive. I have a coworker who uses it at 900 words per minute, and we're going to see what that looks like. The good analogy for eSpeak and all, this is called it's called a Foreman synthesizer, and one of the things about Foreman synthesizers is that they could really, really speed up in a way that what's the word? Concatenating synthesizers cannot do. Okay, so people could really listen to these things very quickly. So that analogy I would use is a monospace font. So if you want to get work done, you want to have a really clear spacing in your fonts, and that's how you would look at your code. But then if you're looking at the paper, you don't want a monospace font. You want a variable width font, and that's the kind of analogy I would use here.
And the warmth and charm of a 1950s science fiction robot.
Yeah, so it sounds like a robot, and this is my coworker Jamie.
So it's saying, perhaps this doesn't cause reflow, so we don't get notified the bounds might have changed, though this needs to be verified. And there's a bunch of code.
List with out of list with step in. White bullet out of list perhaps variant voice volume inflect pitch rate.
So what I'm doing here is I'm using NVDA on my Windows computer trying to fix a bug in some code, and so I'm reading through lots of different pieces of code and letting NVDA read me the information. What you can hear is NVDA speaking very, very fast. Not the whole screen at once, but the information that's relevant at the time. So the current line of text or the current heading or something like that. When I'm reading it at this speed, I'm not necessarily listening to every word. It's almost like when you read a document or when you're skimming your email as a sighted person, you're not necessarily reading every single word. And that's kind of how it is when I'm reading at 900 words a minute.
All right, so those are the problems. Those are the problems we have right now in Linux. I would say the first three problems, boundary events, pause, resume, volume change, if those were the only problems, I think that those are relatively easy features or things to add to our current ecosystem. Concurrent speech, again, which means like not having a global queue, but having like each application or several instances in an application manage their own queues and know that their utterance is going to stop and end. And natural voices are things that I don't think could work in the current framework, and that is why I'm proposing Spiel. So Spiel is more than just a single library. I would divide it into 3 components, and these are the 3 components. One is a dbus interface, another one is a client library, and the third one is a voice distribution scheme, and I'm going to go over those different things. So dbus interface. This is the standard dbus interface. It has 3 members. It has a name, and the name is just a localized human-readable string of what the provider is, eSpeak, Piper, vocalizer, whatever you want. It has voices. Voices is a list of voices, and each voice consists of a human-readable name, a unique identifier, an audio format, and the audio format over here is very similar to the GStreamer one, and I'll get to that soon. And features, it actually advertises features. So I as a voice support SSML. I support, boundary events, but I support words, but not sentences. I support even the dialect of SSML could be specified in the features, and that's important because there's so many different. Each voice will support a different subset of features, and an application developer will want to know when they select a voice which one really is going to be good. And languages. So a voice could support more than one language, but so that is defined as a list. And then there's the synthesize method. The synthesize method takes a file descriptor and it takes all the different arguments that you need to synthesize an utterance, like the pitch, rate, SSML, the language, and then it pipes it all through. It pipes it all back, writes it all to the file descriptor. It could either just send raw audio, just regular audio frames that were defined in the audio format for each voice, or it could send a special Spiel format, which is audio frames interleaved with event data. So you have the word, the sentence, the boundary, all those different things. Okay. All right, so yeah, so this is basically how it would work in the wild. So you have a client, the client, let's say, would be Orca, or would be another speaking application. You'd have more than one provider installed, and the client would basically cast a net, read all the known names on the bus, and yes, we'll get to that problem in Flatpak soon, reads all the names on the bus, figures out which one has a suffix of speech provider, and then it will ask all of those, it will use that interface that we defined. It's going to get the voices for each of these different providers, collate them into a single list, and that's that. This is how synthesis would work. You send a synthesize method, right? And you get audio frames back through your file descriptor. So that's the dbus part, the client interface part. Oops, I just got a captive portal thing. There we go. It's called libspiel. And I tried really hard in this snippet to have it be similar to that DOM snippet that I had earlier. The interface is inspired by the Web Speech API, which, by the way, is inspired by an Apple API. So there's nothing new here. You could see that it's got all the goodies of GObject introspection here, so it will work in any language that will work in. And the features that I would say it has a speaker root. So instead of having like a single global queue, right? You could create as many speakers as you want. Each one will manage its own queue. Because it's receiving the audio frames, which is relatively novel. Usually, in Speech Dispatcher, at least, speech dispatchers would writes to the device, but here we're receiving the audio frames in the client. You could then swap out the sync with any sync you want. So you could add some echo, you could visualize it, you could pipe it over the network, you could save it to file, you could do anything you want with the synthesis. The list of voices is actively maintained and cached, so if a provider is installed or even just becomes activatable, it doesn't need to be spawned or gets uninstalled. or the property in speech providers change, the client library will keep a live list of all the different voices. It will auto-select a voice by language. So if in the utterance you say, I want a French voice, you don't actually have to specify which voice you want. You could just say, this is a sentence in French, synthesize it for me, and it's going to find the right or most appropriate voice for the language and the region. And something that might be really cool in the future is to have like language selection. So you could have like a, today you could have like a little snippet of text, and there are statistical models that you could run to know like what language that's in, and then use the correct voice. And I think another really important thing is that it's all configurable. So the user is going to have a say on what voice they're going to use for each language. And I'll get to that soon. We already have a couple of libspiel ports. Andy Holmes, he ported Orca through STF. I have a work in progress for Firefox that took me a day to do. So it's a very small surface, API surface. And there might be, and we'll get later to what other applications need to be ported, but the other good or bad news, I don't know, is that there are not a lot of speaking applications right now in Linux. I hope that will grow. But there are very few applications right now that actually use speech. So this is a mock-up that Sam Hewitt did, and I think there's one really novel thing about this, and that is the fact, this is the GNOME settings, and the fact that spoken content is not in the accessibility pane. He put it here in the system pane. I think is really important. It shows that the speech could be something that's generalized. It's not something that's necessarily niche or should be considered as like an accessibility feature, and that any application will want to speak, and you should be able to define which voices and for which languages they're spoken. So this is again stored, theoretically this would all be stored in G settings, and libspiel will be pulling that in. So if we look at our task list from earlier, libspiel provides the first four things, right? We have boundary events, we have pause, resume, volume change, concurrent speech. There's one last thing that we don't do or haven't figured out how to fix, and that is natural voices. And that really has to do with distribution. We have right now a problem in Linux that there's really no perfect engine or voice. So if you all of a sudden run into some open source project that like, oh, this is a really cool voice, it sounds really natural, this is something that we should be shipping or giving to our users, you'll notice that either the package is extremely large, it's only available in English or French, or the license is prohibitive. And by that I don't mean necessarily that it's proprietary, but a lot of the new stuff is, especially the neural network stuff, is trained on models, and those will have all kinds of exotic licenses or attribution and things that you will have to take into account if you're going to distribute it. Oh, that was the slide, sorry. So like, for example, in Piper, each voice would be 60 megabytes. If you were to ship all of it, that would be like 8 gigabytes or something like that. So of course, what's the answer? Everybody knows. It's Flatpak, right? Flatpak, you could really like contain a really weird and exotic dependency tree with all kinds of libraries that you would never ever put in any distribution. And it could all be distributed out of band through FlatHub or through any other kind of repository. And it gives you that one-click kind of experience for users who want to try some new AI speech synthesis. They don't have to set up a pip environment and pull in all these ONNX runtimes and all the different things that they need to do, but it all just works with one click. So we can't really bundle it all in one Flatpak. That's kind of the problem. So like I said, Piper's voice data is huge. If you look at eSpeak alone, even though it's tiny, and depends on how you count a voice, it has 102 voices, and each voice supports 132 languages. So that's over 13,000 voices, theoretically. So we need a way to allow users to really just download or install the voices they want and not overwhelm them with like, 1 million voices and not put a strain on their bandwidth. So something that we could do is use extensions, right? The slide somehow got out of sync. So we could use extensions. The problem with extensions, it's a cool idea. You could have like an app or a main, not a runtime, but an app, and then the app could have extensions. The extensions currently in Flatpak aren't considered dependencies of the app. So for it to work, you'd first need to install the provider, you then need to install the voice, and depending on if the actual service is running, you would need to kill it and restart it, because the sandbox obviously doesn't know that a new extension was installed. So there are all kinds of, there's still a lot of friction when it comes to Flatpaks and how that works. AppStream could also use some work. This is a very domain-specific kind of bundle, so there might be some extensions that need to be added to AppStream. For example, for applications, we have screenshots in AppStream. What if we had voice samples for voices? So there's definitely still some gaps in that. So because there are gaps, I created an ad hoc application. It's called like Spiel installer, and it's basically just a giant voice store. So you could go in there, you could search by language, by provider, or by string. You could find the voices that you want, and you could install them. And once you install them, it will, if the provider is running, it will pull in the provider if it's not available, and if the provider is running, it will restart it so that the voice will be available. And I just want to leave you with, so we kind of got all the main gaps covered, and that's one thing. But I really want to let you think about something. Oh. All right, we'll do that later. Let's just watch a demo first. So this is
On October 21, 1976, a small group of cyclists.
So this is
and
a
dog
Piper
named
voice.
Junior
You can already
gathered on
hear that
Carson
it sounds
Ridge.
better. But I want to try a different voice. And it's automatically available in Firefox with no restarts
On
or
October
anything.
21, 1976, small group of cyclists and a dog named Junior gathered on Carson Ridge, which rises just west of Fairfax, California. It was mid-morning and the sky was bright blue, a beautiful day for racing 5-Japan vintage.
Yeah, so that's a demo of how it works. And thank you. Here's another one. In this example, you could see that I don't have an Arabic voice installed. So I could go to the shop, install an Arabic voice, and you could see that the icon just appeared in Firefox because it detected a voice.
تقول الحكمة المأثورة أنت ما تأكله ولكي نكون أدق فأنت تشعر بما تأكله.
And it works.
حيث يلعب الغذاء دورا
It's a natural
مهما في
sounding
التأثير على
Arabic
الحالة.
voice, which is really cool. Yeah. So all of that, by the way, all the Firefox side, all I had to do was put in Spiel, and like this whole like change notification stuff was already there. And because Spiel has change notification of its own, it just all worked. The work here was very minimal. So just something to think about. I'm going to put it out there. Oh, these things don't work. Oh, there we go. I'm just going to let this sit there in the air of the room. But I proposed a solution for synthesis in the form of Spiel. I think a very, very similar solution could happen for recognition, both from a library perspective, a dbus perspective, and distribution. I don't know why the slides are out of sync. And a cry for help, yeah. So I've gotten a lot of help already, and I'm going to get to that. But it's reached the point where technically it does what it does. It's good, and we're at the point right now where we need to grow up. So some of the stuff we need are more providers. Currently, I have an eSpeak and a Piper provider that we wrote, but like you saw earlier in the example, like a provider could be like 200 lines of code. It's not a lot of work, and there are many, many speech services out there that could use it. The top few are open source ones that are relatively permissive, but then you could do really weird stuff. You could like have emulators run voices. You could use Wine, obviously. You could, do cloud stuff if you really want to do that. And obviously, every day, if you're following like Hacker News or some of those websites, you'll see that there's a new AI voice or a new TTS system coming out. And instead of waiting for the go-ahead from different distributions and everything, we could have those really quickly. Like I said earlier, there are not a lot of apps out there right now that speak, and I think these might be it. There might be another 2 or 3, and it doesn't take a lot to port them. So if you want to work on that, and then a part that's really hard for me to do, and would really be good to have some traction, is figure out the distribution bit of this, right? So there's some gaps in Flatpak and the features that need to be ironed out, and finding a hub for this. I don't know if it's FlatHub, but finding some hub. I think voices are obviously not applications, so I think there needs to be a certain other kind of paradigm. So maybe it's a microsite. And as you saw from Sam Hewitt's mock-up, there's work to do in GNOME settings as well. Write a portal. So you saw that earlier that we basically cast a net out and grab all the different known names for the speech provider suffix. That's obviously not possible right now in a Flatpak, so that's going to need to be in a portal in one way or another. It'd be cool if we could do it without reinventing all of the libspiel client logic in the portal layer. So I'd love to hear any ideas about that. And help make it a grown-up project. So we have a website, but we could always have help with documentation, test coverage, continuous integration, release management, and pretty graphics. I think from a coding perspective, this is a very small project. Like, this was really not a very complex thing to do, but I found myself juggling all these different components and keeping them all in sync and having them all work in unison is always a little bit of the harder part. So that's really when it became to be a lot. And I'd like to acknowledge Mozilla for being very patient with me over the last months and years. STF, even though this is not an official STF project, they adopted Spiel, and Sunny's been a big help on that. Andy Holmes has helped with not just the port of Orca, but also a lot of the bug fixes and all the continuous integration and all the other things that make this project work. And other folks who stop by to fix a bug or report a bug and all of that. And that's it. Thank you.
Hi. Hello, thanks for the talk. It was pretty impressive and exciting. I have a few things to say. Can you hear me well? Is it better now? Okay. So the first one is back in 2016, when I was still a happy and excited PhD student, I sketched out a speech recognition service for GNOME. It's called GNLP, and it was actually working. Was using Julius, the project Julius for speech recognition, and it was able to recognize Hey GNOME and Open Calendar. Maybe we should bring that back to life or something.
This is from the recognition side, right?
Yeah.
Yeah, very much so. Like,
it just executed it,
reincarnate it, and
yeah.
Yeah.
The second thing I wanted to mention is that we're going to have a Flatpak and Portals workshop in the last day of GUADEC. If you're still around, please.
Yeah, I'm very much looking forward to that.
Okay,
yeah.
Fantastic. Yeah, thank you.
So the status quo with FlatHub right now is that when you have to ship apps with icons, and they actually have to be like an app you can launch, why not have these voice providers like you install, I don't know, Piper, And Piper would just be an app, and you can download voices from within the Piper app, and then it would provide a speech provider that way. That would be like a less. It's kind of like what you've done, but per speech provider.
Right. I think I considered that. I think there's obviously duplication of effort. I don't think that's the important part. The duplication of effort would be fine if that was the only cost, but I think there's a cost for the user of understanding like this is a new provider and this is how I get voices for it, as opposed to just having a unified experience of that's what I was going for, basically. But yeah, that would have been the easy way out, is to have an app with a UI. These providers don't have UIs, right? So that's the other part that probably doesn't let them currently at least get listed in FlatHub. And that is why I'm proposing some sort of, it doesn't have to be FlatHub, maybe there's some other kind of repository that would have a different kind of paradigm and have a different kind of relationship between provider and extensions and make that work.
Any other questions? All right, I think that's it.
Great.
Thank you
Thanks
so
so
much.
much.